or when we are going to talk of the composition of the function, it is one way of combining function. That is the same as addition, that is the same as subtraction, multiplication, division. So we combine, okay? We combine function, but you notice that when we combine functions, we have to go over, okay? We have to recall the idea of evaluation, okay? So evaluation of what? Of functions, just the same. So in the evaluation of function, we make use of the substitution method. Okay? So this is the ideas or concept that will go together. Every time that we are going to have the evaluation of function, this will always go together. Okay? So evaluation and substitution of functions. Okay? If we are talking of evaluation, you remember that when we evaluate, shall we say we have in here, f of x is equated to x raised to 2 minus 4. Now, how do we evaluate? How do we evaluate this one? We have said last time that when we evaluate, we get the domain. Okay, we get the domain. And what are the domain? We have said that the domain are all real numbers. So if the domain are all real numbers, so we can assign the value of x. It could be negative numbers. It could be negative 3. It could be 0. It could be positive 3. Or all be negative, all be positive, including the 0. So that is the meaning. Now, notice that when we are going to evaluate this one, we just try to replace the x with this number. Okay? So saying that what would be the value of the function f of x if our x is negative 3? What are we going to do? We just replace, saying now that f of x, which is negative 3, is the same as the quantity negative 3 raised to 4 is equal to 4. And that is how to evaluate. We evaluate, we substitute. Meaning, after substituting, that's the time we're going to solve. So we have now that is the same as negative 3 multiplied by, we have exponent, negative 3. And minus 4. Or negative multiplied by negative, positive. And so positive 9 minus 4. And so the result of your f of negative 3 is the same as what? 5. That is the idea of what? Evaluation and substitution. What about if we are going to evaluate the x, or x is considered to be positive 3? So how are we going to have? Or what would be the value of f of x? What will you do? You just replace. So by saying f of 3 is the same as 3 raised to 2 minus 4. So it will give you just the same. That is 9 minus 4. When we are going to have the composition of the function, we follow the evaluation and substitution. Now let's try to have. So when we talk of composition of function, we consider our notation. What would be the notation of composition of function? The notation would be that is f function compose g function of x. Okay? What will give you? That is f of g of x. That is the result. Meaning, if this is the result, this is the one that we are going to follow. Now notice that in the ordinary function or evaluation, what we are trying to use is just the value of x. But in here, what we are going to use as the value of x is the function itself. So, how are we going to make use of that one? Well, let's try that. So, f of x is equal to, we make use of the same, x raised to 2 minus 4. But what about if our g of x is equal to 1 over x plus 5. Oh. So if we are going to combine them, what would be the result? So how do we combine them? Meaning, we use this one. We use this one. So that is the same as we have in here, f of g of x is what? The same as our unknown. Our unknown. So how do we evaluate? We copy the outer function. What is the outer function? Our outer function is actually f of x. So this one. What is our outer function? F of x, which is already defined. So ito, x raised to 2 minus 4. And so, when we are going to have now the composition, we change the x. With what? G of x. So, you notice that we're going to change it now. We have that is the same as G of x. Now, we have already substituted this one. What would be the next? You replace. Substitute. So that is the same as G of x raised to 2. We have already changed this one or replaced. And that is the same as 4. But our g of x is what? This one. G of x is equal to 1 over x plus 5. And so with that, we replace again. So meaning to say, we put an arrow so you can follow. Meaning, we have in here, we change. Okay? By saying that our g of x is 1 over x plus 5. We have already replaced the g of x. What will you do here? Replace it also. Substitute. So meaning to say, what will you use? That is 1 over x plus 5 raised to 2. Minus what? Minus 1. So after that one, that's the time you're going to evaluate. Now let's try to have. Let's try to have. Meaning to say, 1 raised to 2, that is the same as 1. X plus 5 raised to 2, it will give you x plus 5 raised to 2. Minus 1. What are we going to do? Expand. We will expand. So if we will expand, following the exponent of our denominator, we say that is the same as f of 1 over x plus 5 is equal to, we follow now the denominator. So we say x plus 5 multiplied by x plus 5. Minus what? Minus 1. Minus 1. Very following. Next. Following x multiplied by x raised to 2. X multiplied by 5 plus 5x. 5 multiplied by x plus 5x. Then 5 multiplied by 5. What is that? Plus 20. 25. Oh, of course, that is 1. Minus 1. Let's continue. Combine. So that is the same as what? 1 over x raised to 2 plus 10x plus 20 25 minus 1. What is the LCD? Our LCD is our denominator. So x raised to 2 plus 10x plus 25. This trinomial x raised to 2 plus 10x plus 25 divided by design. So 1. 1 multiplied by 1, and that is 1. So cross multiply. And so we have now, that is the same as negative 1 multiplied by x. X raised to 2 plus 10x plus 25. Let's continue here. Okay, now, after that one, we combine now, that is the same as distribute. And distribute. Okay, so we have now, ito, 1 minus distribute, negative, x raised to 2. Distribute, negative, 10x. How about here? Negative 20, 25. Over the denominator, x raised to 2 plus 10x minus 25. You notice, 1 minus 25 can be subtracted. So it will give you now negative x raised to 2 minus 10x. How about here? Minus 20, 24. Over what? The denominator x raised to 2 plus 10x plus 25. So that will be now our final result. Our function is defined to be f of x is equal to x raised to 2 plus 2x plus 1. And another function is g of x is equal to x raised to 2 minus 1. Now, what would be the result of g compose f function of x? What would be the result? Definitely, the result will be what? G of f of x. Now, we just follow, okay? So, we will evaluate now using the definition of f of x, which is x raised to 2 plus 2x plus 1, okay? And of course, g of x is equal to x raised to 2 minus 1. Now, what is our outer function? G of x. What is the g of x? X raised to 2 minus 1. Now, the next thing now is we change your x. So I repeat, when we evaluate, we always start with the outer function. Okay? Now, so that we will be having now g of f of x. So we replace. We will also replace this one. We substitute. So it will give you the quantity f of x raised to 2 minus 1. But remember that your f of x is defined. So what are you going to do? Meaning to say replace. So that is the same as what? Let's try to have g of, what is that? X raised to 2 plus 2x plus 1. Because you have changed this one, you change also. So you have now, that is the quantity x raised to 2 plus 2x plus 1. But that is being raised to the second power. Or raised to the second power. So minus 1. Okay? Are we done? Not yet. We expand. We will expand. So trinomial multiplied by a trinomial. And so let's try to have it here. Okay? That is the same as, let's continue it in here. That is the same as saying x, the quantity x raised to 2 plus 2x plus 1 multiplied by x raised to 2 plus 2x plus 1. This one. Okay? So we have in here. Originally, minus 1. Let's continue. So, distribution. That is the same as x raised to 2 multiplied by x raised to 2. We have x raised to 4. X raised to 2 multiplied by 2x. We have 2x raised to 3. X raised to 2 multiplied by 1. That is the same as x raised to 2. Now another one is we have in here now 2x multiplied by x raised to 2. It will give you positive 2x raised to 3. Multiply, it will give you 4x raised to 2. Are you following? Then multiply, that is the same as positive 2x. What's the next? This one. You distribute. 1 multiplied by x raised to 2. Positive x raised to 2. 1 multiplied by positive 2x. Positive 2x. 1 multiplied by 1. Positive 1. Minus 1. Okay? Now, combine now the similar terms. So, are there terms similar to this one? There is none. So, we just copy. X raised to 4. Are there similar terms to this? We have. So, we have, what is that? 4x raised to 3. Tama? Now, next. Are there similar terms similar to x raised to 2? We have. Ayan. So, what is that? That is the same as, and then, we have 6x raised to 2. X, this one, are they similar terms? That is the same as plus 4x. What about this one? This one? Oh, 0. So that would be now our final result. Okay. So we have in here two functions. Their definition, we have in here 2x plus 5 and x raised to 2 minus 4. Now, let's try to apply now. Let's try to get its composition. So we say the composition of f of g of x is the same as we copy first the outer function. So what is the outer function? That is 2. Okay? 2, our x, supposedly, is what? G of x. G of x. Are you following?
Yes.
Wait. And then, that is, what is the next now? The f of x is the same as, or defined as, plus 5. Okay, plus 5. Plus 5. Now, let's try to copy the f of x, the outer function. Our f of x is the same as 2x plus 5. What is our x? g of x. What is our x? 2x. Our x is g of x. Okay, next. What is the next thing that we are going to do? We will get the definition of this one. What is the definition? We write it down. The definition is x raised to 2 minus 4. So x raised to 2 minus 4. We change it. We will also change this one, substitute. So that is the same as 2 multiplied what is the g of x? X raised to 2 minus 4 plus 5. Continue our computation. Definitely, we will distribute. We have 2x raised to 2 minus 8 plus 5. Final answer. 2x raised to 2 negative 8 plus 5. Addition of like sides. Okay? So the result of f of g of x is already 2x raised to 2 minus 3.